Welcome to solverfy.
Alright, so for this problem, they are wanting us to find milliliters of bubbles at standard temperature and pressure for this problem. But before we can find it at standard temperature and pressure, we first need to find it at the conditions that they gave us. So they gave us that our pressure is equal to 1,450 mmHg. And then they gave us the temperature at 286 Kelvin. They say that our volume of our gas or our air is 208 milliliters. I'm just going to convert this straight to liters, so 0.28 liters. And then for this equation, I'm going to be using R is equal to 62.36 liters times millimeters of mercury per mole Kelvin. Alright, and then we're going to be using our equation PV is equal to nRT. And we're going to be looking for moles of the gas that is produced. So N is going to equal our pressure times our volume of air, and we're going to divide that by our R value, which is 62.36 liters per millimeter of mercury per mole Kelvin. And then we're going to times that by our temperature, which is 286. I'll put Kelvin on there. Kelvin. Alright, so when we calculate this out, our number of moles is going to equal 0.01691 moles. Alright, so for part A, they're wanting us to find this at standard temperature and pressure. So standard temperature and pressure is, our pressure is equal to 1 atmosphere. And 1 atmosphere is also equal to 760 millimeters of mercury. And our standard temperature is equal to 298 Kelvin. So again, we're looking for our volume. So V is going to equal nRT divided by our pressure. So this is going to look like, we're just going to use the moles that we just found. So 0.01691 moles. And we're going to times this by our R value, 62.36 millimeters of mercury per mole Kelvin. And I'm just going to continue writing on the next row, and then we're just going to times this by 298 Kelvin, and then we're going to divide all of this by our pressure, which is 760 millimeters of mercury. I'm just keeping the units of mercury the same. So our volume, when we do this, is going to equal 0.4135 liters, and they want this in milliliters, so volume is going to equal 413.5 milliliters. And this is what our volume of gas or air would be when the bubbles are released at standard temperature and pressure. And then for part B of this equation, they want us to find the moles of nitrogen in the air. So again, we're going to be using PV is equal to nRT. And let's get our pressure into atmosphere. So we're going to do our pressure is equal to 1,450 millimeters of mercury. We're going to divide this by 760 millimeters of mercury per atmosphere. So our pressure is going to be 1.98 atmospheres. Alright, so again, we're looking for the number of moles. So our equation is going to look like N is going to be our new atmosphere, so 1.908 atmospheres. We're going to still use the same volume, so 0.208 liters. And we're going to divide that, and I'm going to use a different R value this time, so 0.0821 liters atmosphere per mole Kelvin. And then I'm going to times that by the temperature that they gave us, which is 286 Kelvin. Alright, and then this is going to equal out to be 0.01690 moles. Alright, and then to find the moles of nitrogen, it says that our air bubbles consist of 77% nitrogen, so we're going to just turn that into a decimal, which is 0.77, and we're going to times it by this number of moles, 0.01690 moles. Alright, because this is the total number of moles, we only want 77% of this, because that'll be the percent of nitrogen. When this is calculated out, it's going to equal 0.0130 moles of nitrogen, and this is the amount of nitrogen in the air bubbles released.